Our topic is latch and flip-flops. Latch and flip-flops are the storage elements. They can maintain a binary state indefinitely as long as power is delivered to the circuit until directed by an input signal to switch states. Storage elements that operate with the signal level are called latches, and those whose state changes with the clock pulse H or clock transition are called the flip-flops. A latch or flip-flop is a cross-coupled NOR gate or the cross-coupled NAND gates. Now we have drawn a function table for a latch or a flip-flop with NOR gates. So on the left side we have inputs S and R, and on the right side we have outputs Q, Q dash. First of all, we give the state S is equal to 1 and R is equal to 0, and at the output we will get Q is equal to 1 and Q dash is equal to 0. This state is called the set state. Then we give S is equal to 0 and R is equal to 0. So the output remains the same, that is Q1 state and Q dash 0 state. So it is the previous state. Then we give S is equal to 0 state and R is equal to 1 state. We can see Q is equal to 0 state and Q dash is equal to 1 state. It is called the reset state. Then again we give S is equal to R is equal to 0 state, and the circuit remains in the previous state, that is Q is equal to 0 state and Q dash is 1 state. Then we give 1 state to S and R, and we can see the output, both the outputs Q and Q dash are in the 0 state, which is not possible because in the logic diagram we can say that one output is Q and the other output must be Q dash or the Q complement. So in this state both the outputs are in the same state, which is not possible. So this state is called the unused state. Now the logic diagram of the latch or flip-flop with NOR gates is drawn. In this diagram, we have two inputs R and S. R is the reset input, S is called the set input, and we have two outputs Q, Q complement. If we give 1 state to S and R, and when we can see that if NOR gate has one input is equal to 1 state, then definitely the output will be 0 state. So if we give R is equal to 1 state, then Q will be 0 state. Similarly, if we give 1 state to the S input, then definitely the output, that is Q complement, will be equal to zero state, which is not possible, and that is why this state is called the unused state. Now we can verify the function table one by one. If we give S is equal to 0 state and R is equal to 1 state, then if R is equal to 1 state, then definitely output of this NOR gate must be 0 state. NOR, due to the cross coupling, this 0 goes to the input of the other NOR gate, and the S input is 1 state, and therefore the output will be 0 state. Then we have function table of latch or flip-flop with NAND gates. Now in this diagram we have cross-coupled NAND gates. Cross-coupling means that input of one gate is connected with the output of the other gate, and the input of the other gate is connected with the output of the first gate. So it is called the cross coupling. So we have in this table SR inputs and QQ dash are the outputs. If we give S is equal to 1 state, R is equal to 0 state, then output Q is 0 state and Q dash is 1 state, which is called the reset state. Then we give S and R both 1 state, then output remains in the previous state, that is Q is equal to 0 state and Q dash is equal to 1 state, and this can be verified by the logic diagram. Then in the third row we have S is equal to 0 state and R is equal to 1 state. Then we will get Q 1 state and Q dash 0 state, which is called the set state. Then again we give S and R both 1 state, and the circuit will remain in the previous state, that is Q is equal to 1 state and Q dash is equal to 0 state. Then at last we give 0 state to both S and R, and the output will be 1 state, which is not possible because one output must be complement of the other, and which is not here. So that is why this state is called the unused state.